Hi everyone. In this video, I'm going to show you guys how to find equations of tangent lines and normal lines to a trig function, to a trig graph. Okay, so let's take a look here. In this question, they want us to find the equations of tangent line and the normal line to the curve at x is equal to pi over 4. Alright, so this is my x value. Right? When we are drawing our trig graphs, most of the time my x-axis would be either radians or degrees. Right? So in this case, my x-axis, my angle is in radians, and that it is pi over 4 radian. Okay. Another thing that I would like to point out is the normal line. Normal line means the same thing as perpendicular line. Okay. So the first thing we need to find the equation of the tangent line, and then the second task is to find the equation of the normal line. Right. So let's get started. The equation that we have, the function, the curve, right, the trig function here is f of x is equal to 2 tangent x. So you can see that the function, we can see a very typical tangent graph, and it just repeats for an interval of pi. Right? The period for tangent graph is pi. Okay, nothing new. Now, they want us to find the equation of the tangent line at a specific point. The point is x is equal to pi over 4. So pi over 4, right? That's my point. That's my x coordinate. So we don't have the y coordinate, but we have the equation. So what I'm doing here is I'm just putting the equation in there. Right? I'm putting the pi over 4 in the equation. So 2 times tangent of pi over 4, and that gives us that point, which is pi over 4 2. All right. So this is pi over 4 2. All right. So I'm going to use that. I can delete. I don't have to show that now. So the green point, this is my the point that I'm interested in. Right. So the tangent line is going to be somewhere here. It goes down as I go to the left, it touches the green point, and then go back down. Right. So it's like this is my tangent line should somehow has a positive slope and cuts my tangent curve once at the green point. Pi over 4 2. This point. Okay. Okay. So in class we already came across this equation. Right. We learned that the derivative of tangent x is simply 1 over cosine squared x. Right? The derivative of tangent x is 1 over cosine squared x. So right now, my f of x is 2 tangent x. Then the derivative of that will be 2 times the derivative of tangent x, which is 1 over cosine squared x. Does that make sense? Right? So which means I can simplify this, and this becomes 2, and I can take that out and remove the 2 in the front. Right? Okay? And if this looks weird to you, I will change the way it looks a little bit. So this is cosine x, but the whole denominator would have a power of 2. Right? So what I have done just now in a couple of seconds, in the past few seconds, I'm just manipulating the way it looks, but they all mean the same. Okay, so my g of x is the derivative of my f of x. Okay, so now what does the derivative give us? The derivative gives us slope, correct? So I can find out the slope at this point, at this green point, by substituting the pi over 4 into my derivative expression. Right, into my derivative expression. Okay, so now we just have to find the slope at, this is pi over 4. And my y in this case is 2. Right, so find the slope. The slope will be, I'm just going to copy this. I'll copy that, put that here, because that is my derivative expression. Now I know my x is equal to pi over 4. No x anymore. The x becomes pi over 4. Right, so this becomes pi over 4. Oh, okay. Let's remove some parentheses here. All right. So 2 over cosine pi over 4, the whole thing squared. That gives us 4. So my slope at the green point, my slope is 4. So now I can use my point slope form, which is over here, my point slope form, and figure out the equation of the tangent line. In this case, since my tangent line is going to touch the green point, then my x1 will be pi over 4, my y1 will be 2. Right, so let me start by doing that. So y minus my y1 is 2 equal to my slope. What's my slope in this case? We just found that. My slope at this green point is 4. So that's 4 multiplied by x minus my x in this case is pi over 4. Pi over 4. Okay. There you go. See that? The green line is the tangent line. Right. So if I zoom out a little bit, you can see that my green line touches that point once. Okay. Even though it touches the tangent graph again over here, but that's not really a tangent curve. Right? It's not. This line is only a tangent line to the pi over 4 2. This point right there. Over there, that's not a tangent line, okay? That's not a tangent at that point. Okay, now, what about the perpendicular line? So to find the perpendicular line, we need to do something with the slope, but everything else stays the same, right? So let me copy that. So let me show you the relationship between your slope of tangent line and the slope of your perpendicular line or normal line is this. Okay, so here it is. This is the relationship between the slope of a line and the slope of the perpendicular line. Right. So you see that the slope of the perpendicular line is just -1 over the slope of the line it is perpendicular to. So right now, my m would be the slope of my tangent line, right? So my normal line, my perpendicular line, would have a slope of -1 over the slope of that, which is 4 in this case. So I would have to change this 4 to -1 over 4. And if I show this equation, I should see a perpendicular line passing through pi over 4 2. Let's do that. Let's see if that's true. Okay, something's wrong here. Let's see what's wrong. Why do you think the lines, the blue line, which is my normal line, the green line, which is my tangent line, they don't look like they are they are perpendicular, they are normal to each other? Why do you think that's the case? Mathematically, algebraically, we have done everything right. But right now, they don't look like they are 90 degrees because of the scale. See how wide this 2 is and how short this 2 is, right? This 2 is a lot shorter. This 2 is a lot longer. So right now, our graph is sort of horizontally stretched. So if I change this, right? So now this is 2. This is also 2. So now you see that the blue and my green lines, they are right angle at each other. They are normal to each other. Okay? Alright, feel free to rewind this video, and I hope you guys find it helpful. The key point in this video is to know how to find the derivative, right? You need to be able to find the derivative, the expression to your original function, original trig function, because with that we have the expression to the slope, and then here they want us to find the equation of a tangent line at this specific x. So that's why I have pi over 4 here, right? And we just carry out, we're just going to use the point slope form to get the tangent line, and then lastly the equation of the normal line. Alright, I'll see you guys in the next video. Bye.